Welcome to Climate and Sustainability Risk series, where we simplify complex climate concept and help you build expertise rooted in various global frameworks. I'm Jay Shah, your guide for this whole journey into climate and sustainability risk, whether you are into this profession, into ESG, climate and sustainability, or you have just started your career into sustainability field. So this is the right place for you. Let's get started. Climate change is one of the most pressing challenges of our time that we already know. But what exactly is it? Climate refers to long term patterns in temperature, humidity, wind, and season. So that is different from short term weather. Modern climate changes that mentioned in the slides changes refer to the rapid shift in climate patterns we have seen in the last century, and that is because of the human activity. Few of the evidence that I already mentioned in the slides that it's all around us. Retreating glaciers, sea level rise, global temperature rising, and increase the frequency of extreme weather events. These events, based on the satellite data, ice cores, and ocean heat that are generating very fast, that records all the points to an accelerating this trend. The Earth has always undergone with the climate change long before the humans that we already know. So natural process like volcanic eruption, solar cycles, Milankovitch cycles, so that all are Earth orbital variations. So that is have driven changes over the millennium. Uh, Paleoclimatology studies that have done by the ancient climate scientists that are using by the tree rings, ice cores, and ocean sediments that mentioned in the slides as well. So reconstruct this temperature and the carbon levels, helping us to understand what's natural versus the human induced into the climate change. The climate system is governed by Earth's energy balance, how much solar energy comes in versus how much is reflected or radiated back to the space or the sun. This balance keeps our climate is stable. So disruption to this balance, such as increase in greenhouse gases like CO2, CH4, N2O, these greenhouse gases trap more heat in the clouds that causing planet to warm. So because of this effect, Earth is very becoming a warm and they generate a more GHG emissions and that reflect back to the Earth. The greenhouse effect is a natural process where gases in the atmosphere trap heat, keeping the planet warm, but human activities have intensified this effect due to various human activities. So, key greenhouse gases include carbon dioxide, methane, nitrous oxides, fluorinated gases. Without the greenhouse gas effect, Earth would be frozen planet, but too much of it leads to global warming. How human can impact the climate change? So human activities, mainly burning fossil fuels, deforestations, and industrial process, are increasing this greenhouse gas concentrations. So CO2 levels on the clouds are now higher than at any time in at least 800,000 years. The Industrial Revolutions marked the turning point in human impact on the climate change. As you can see that these are the impact of human for the climate change, and lots of human activities are impacting overall Earth climate change. Attribution science help us to understand how much of climate change is due to human versus natural causes. Models shows that without human emissions, recent warming trends cannot be explained. The IPCC state with high confidence the human influence is the dominant cause of observed warming since the mid 20th century. In summary, the evidence is very overwhelming. While natural factors influence climate, the rapid warming we have seen in recent decades is primarily due to the human activities. And this is the critical basis for the policy, finance, climate risk management, and all over the sustainability decarbonization strategies. So this is very important to understand how human activities is affecting to the climate change. So now here is the very interesting task for climate professional and climate experts who wanted to understand about the climate risk assessment and how it's work. So to plan for the future, climate scientists or the data analyst or the ESG and sustainability professionals use various scenarios and call as a SSPs, which is a shared socio-economic pathways. So this combine possible global development trends with emissions trajectory that represent the various scenarios. So, for example, SSP1 represent a sustainable path, while SSP5 that assumes high fossil fuel use. So, if the regular use of fossil fuel is using, then what will be the impact on the Earth? This scenario shaped everything from the climate models to the national policies as well, and for the company level, corporate level, enterprise risk management. So we'll see in details in coming chapters and the coming sessions that how it's work for the scenario analysis for the climate risk assessment. Climate change affects everything: biodiversity, agriculture, water, health, and more around our neighborhoods through the various floods, drought, and major extreme weather impacts. So some of areas face various floods, droughts, small islands, nations that are under the risk submersions, and lots of social impacts are also unequally distributed. When flood is coming, that vulnerable populations face the worst consequences despite the contributing into the GDP. So it is very important to understand how we can tackle this vulnerable populations, how we can tackle this physical climate, and how it's work. So that is very important for the sustainability and climate risk assessment. Now, for the climate change impact, there are so many of different solutions that we should adopt. First is adaptations. So adaptations means is adjusting to the climate impacts, like building flood defense, switching crops, or developing early warning system at various cities level things and the state and national level. However, not all the adaptation is very good. So we need to understand what are the adaptation things that we can create a new vulnerabilities. So especially with ignores very social and ecological context. So these are the very important points that we should understand that what adaptations projects that we should take up. Second is mitigations to address the root cause and reducing emissions. It includes renewable energies, efficiency, sustainable transport, and nature-based solutions. So it's not just about cutting carbon or CO2 or any GHG gases. It's about transforming whole systems that how we already build and what we can move towards the sustainable and the grow towards the climate impact. Third one is geoengineering. So geoengineering process radical interventions to cool the planet. So it is very scientifical process that can be done. So lots of reflecting sunlight or capturing CO2 at scale. Those are part of the geoengineering analysis and intervention. So while promising these techniques and carry risk and ethical questions, geoengineering is not a substitute for the mitigations and adaptations. So, for example, recently UK announced that they are going to do something with the climate interventions with that clouds, and they are just limiting sunlights coming to the earth. So that is called as a geoengineering intervention. So that is very good scientific solutions, but the risk and the impact can be different. So it is not a substitute for the mitigations or adaptations, but we should consider all the risk and ethical questions whether if we are doing this kind of geoengineering service that UK already is doing, then what are the impacts? What are the impacts on the precipitations, or what are the impact on the rainfall? So these questions should be there. Thanks for watching this. If you found this helpful, like, subscribe, and share with your friends and the professionals, the passionate about climate and sustainability. Next, I am going to cover sustainability. session and drop your questions in the comments or connect with me on the LinkedIn. Let's keep learning and leading on this climate.